In a previous video, we have discussed that the humans make connections between different parts of the text when they read a document to understand and to fill any knowledge gaps. In a RAG system, we split the document into multiple chunks and we treat those chunks independently, right? So we do not make any connections between those chunks. In a GraphRAG, we build high-level communities and the community summaries with the aim to answer the global questions more accurately. For example, questions like what are the main ideas discussed in the book, right? And then we have discussed a new method which is superior to RAG potentially, which makes the connections between different chunks via the nodes and the atomic facts. Okay, so we build the graph using this 4-layered approach where we start with our documents and we split them into chunks as in a traditional RAG system, and then from each chunk we derive atomic facts, which are very concise statements containing some information. Okay, then from chunks we derive the key elements or the nodes as in a traditional knowledge graph, right? For example, let's say chunk 3 and chunk 1, which are in different parts of the document, have discussed about a person, right? So these two chunks are connected by that person in the form of key element here, right? The atomic facts related to the person in chunk 3 and chunk 1, they can be different, okay? But since those two chunks have discussed the same idea, they will be connected by that particular node, okay? And we also maintain this relationship for each chunk which is preceded by and followed by which other chunks. We also maintain that relationship, okay? So using that approach, we have taken this zone of arc as an example document, just a single document, but we can have multiple documents. So this document we split into 4 chunks which are in blue, chunk 1, 2, 3 and 4, and then from each chunk we derive these atomic facts. Okay, so we have 43 atomic facts which are in yellow, and then from each atomic fact we derive the nodes or the key elements which are 2 and 6, as you can see in this the green color. Okay, so we have built a graph. Today we will build an agent which takes the user query as an input and devise a plan, explore this graph to extract the relevant information in order to answer the user query more accurately. Okay, all right. So this is a very long notebook, so we will not go into all the details, but we will cover the important aspects. All right. So the agent start here. It takes the user query and first it devises a plan how to answer the user query, and then it selects some initial nodes. Okay. So from these green colored ones, it select a few nodes which are relevant to answering the question. Okay. Since the nodes are connected to atomic facts, it pull the atomic facts related to those nodes. Up to this point, the process is fixed. Okay. So for, let's say the first 4 nodes, the process is fixed. And then based on these atomic facts, the agent will decide if it needs to extract the relevant chunks from which the atomic facts are derived, or if it needs to extract the neighborhood nodes. Okay, so in these dotted lines, at every step the agent will determine which is the next best action to take. Okay, so in this process, within these 3 nodes, the agent will extract all the relevant, explore the graph and extract all the relevant information needed in order to answer the question. Once it extracts all the relevant information, it goes to this node, which is where the answer is synthesized, and we end the process. Okay, so in LangGraph terminology, all of these are nodes. Okay, all right. Now we will go into the details of each node, how it works, but let's take top-down approach. So we start high level and then we go into the nitty-gritty details. Okay, now we will come to this state part in a second. The state is simply what information we are passing between different nodes. Okay, for example, between these two nodes, a plan is passed because this node creates the plan, and then that plan get passed to this node, right? So the state simply represents what information has been passed. So initially we have the user query, so that's the input state, and the output state, which contain the final answer as well as some explanation and the steps which have been taken. And then the overall state, which contains all the information which is passed between these nodes, right? So as I mentioned, the agent explore the graph autonomously to collect as much information as needed, and it could be taking multiple steps, especially here. Okay, all right. So that's what this overall state contains. So we initialize the graph, and then we add all these nodes. We will look into the definition of these nodes, but so here we have a rational plan node, initial node selection, or and then so rational plan, initial node, and then these three nodes, which is where most of the action happens. So atomic fact check node, chunk, and neighbor select, and finally we have answer reasoning. Here we are simply adding the nodes, so the order doesn't matter. Okay, this order matters. Okay, so we start. Okay, so we start the process here, and then we next go to this rational plan node. Okay, so from rational plan node we go to initial node selection. So here we devise a plan, what steps the agent need to take in order to answer the query, and then here we select the appropriate nodes. Okay, so we are going from most granular information to higher level information. Okay, so initial node selection, and from initial node selection we go to atomic fact check. Okay, so up to this point the 4 steps are fixed for any given query irrespective of the query. Okay, but once we are at this atomic fact check, now we have 2 options. Either we can go ahead and extract the chunk information, or we might decide that we might not have enough information based on these atomic facts, so we might go ahead and select the neighborhood nodes. Okay, so either this or this. So what we are doing here is we are adding a conditional edge from this atomic fact check. Okay, and which step it take is determined by this function, atomic fact condition. So the outcome of this function is one of these 2. Okay, it's simply which route to take. Okay, similarly when we are at and then if it's at a chunk check, again similarly it can take 2 routes. One, it can explore further chunks within the neighborhood, or it can go for neighboring nodes selection. Okay, that's what we have here. And then we have neighbor select. So once the agent collected sufficient information, we pass all that information to this answer reasoning node, which is where the answer is synthesized, and then that's the end. So we compile the graph, and this is just to display the schema. Once we have the graph or the agent, we can invoke it by start asking the questions. Okay, all right. Now let's see these nodes. So once you understand how these nodes work, the process is very much similar for all of these nodes, and each node will have a very long prompt describing what the overall graph is, what's the specific action the agent supposed to take at each node, so on and so forth. Okay, so we looked at the steps at a high level. All right, now first I'll show you the states. Okay, selection state. Okay, overall state, let me search for this. Yeah, so these are the 3 states we have. As I mentioned, the input state, which simply takes the query, and the output state, this is at the end of the node, which has an answer and some analysis, and we want to trace all the steps taken by the agent. So here we, in this previous actions, which is a list, we will have all the steps taken by the agent or the path traveled by the agent. Okay, then the overall state, in addition to these 4, we will have what information being collected from the graph at different steps. Okay, for example, we are collecting the atomic facts, we are collecting the chunks information, and then we are checking or we are collecting the neighborhood of the chunks, so on and so forth, right? So this is all the information passed between different nodes of the graph. Okay, all right. So let's start with the rational plan node, right, which is what our first node is. So here we have the prompt, okay, where we are simply saying, hey, you are an intelligent assistant, your objective is to answer the questions based on the supportive information. Okay, now the main one is here, to facilitate this objective, the first step is to make a rational plan based on the question. So see this, a rational plan based on the question. Okay, now the plan should outline the step-by-step instructions, so on and so forth. Here we have an example which says, who had a longer tennis career, Danny or Alice? Okay, now here, in order to answer this question, first we need to figure out the Danny's tennis career, Alice's tennis career, which can be based on if when they started and when they retired, and then finally we can compare their careers, right? So that's what the steps. Okay, so we gave an example, that's our prompt. Here we have created the prompt, and then we are creating this node here. Okay, so which is simply invoke this chain, rational chain, with the query. So it takes the query and it divides a rational plan or a step-by-step plan to answer the query. Okay, all right. So this information get passed to the next node, right? Which is the initial node selection node. Okay, so along with the output, we also pass the previous states. Okay, which is what we have here. So the previous actions, the rational plan. Okay, after rational plan, we go to the initial node selection. Okay, now we have initial node selection. Obviously, now we are going to extract the data from the graph. So we need to first connect to the graph. Okay, so here we are connecting to the graph and we are extracting the nodes. Okay, so we are extracting node level information. So as you can see from the retriever query. All right, so using this vector similarity, we extract a bunch of nodes along with the similarity score. All right, this is the prompt. So for all the following prompts, first we describe what our graph is, what our objective is, etc. at a high level, right? So as an intelligent assistant, your primary objective is to answer the question based on the information provided. To facilitate this objective, a graph has been created from the text, okay, comprising of these three elements. The graph has 4 elements, but the document level information we won't be extracting, right? Otherwise we don't need, if we can pass the full document as a context to the LLM, we wouldn't be needing any rags or GraphRAGs or this graph reader, right? So we have the nodes at a very granular level, which can be nouns, verbs, adjectives, etc. And these nodes are derived based on atomic facts, which are the smallest individual truths extracted from the text chunks, right? These atomic facts are derived from these text chunks. Okay, all right. And then that's the information. Okay, your current task is to check a list of nodes with the objective of selecting the most relevant initial nodes from the graph to efficiently answer the question. Okay, you are given a question, so we will be giving the question, the rational plan, and we are asking the agent at this node to extract the relevant nodes. Okay, all right. So, and I'm not going to go and read the full prompt, but here we are asking, okay, give it a score, so on and so forth. Okay, you can read that. All right. So again, we construct the prompt, and so we will be using Pydantic heavily at each node. We define the classes so that it knows the output format. So basically, to enforce the output format, we will be using this Pydantic based model. Okay, so the output will be the key elements, which is this relevant nodes, and for each node we will be having a score between 0 to 100, how relevant the node is to the question. Okay, these are the initial node which contain the full list of nodes. Okay, again we devise a chain. Okay, this is our node function. We invoke, and the input is simply the question, the rational plan, and all the nodes. Okay, so it takes these 3 as input, and the output is going to be the filtered or initially selected nodes. Okay, all right. And then to the next one in the graph, we will be passing the initially selected nodes. Okay, so here we are simply sorting the nodes based on the score, and we will be passing only the top 5 nodes. Okay, so for these 5 nodes we are going to check the atomic facts. Okay, and then for the next node we are informing which are all the previous steps taken. So this is a list, as you can see, the initial node selection, so that has been done. And then atomic fact check. Again, going back to our graph, so we have done the rational plan and then the initial node. So we have selected the top 5 relevant nodes to our question, and then for those questions now we are going to extract the atomic facts. Okay, text chunk, atomic facts. Okay, again, as I said before, so we provide all the background information, and then now we say, okay, your current task is to check a node and its associated atomic facts. Okay, we already have the nodes, and extract the atomic facts and check if they are relevant to, or if they are useful in answering the user query. Okay, so with the objective of determining whether to proceed with reviewing the text chunk corresponding to these atomic facts. Okay, so you will be given a question, a rational plan, the previous actions. By the way, I haven't introduced this notebook concept. The notebook is simply a placeholder for the agent to gather the information as it travel through the graph. Okay, so maybe let's spend a second here. So we build the graph. Here the user asked a question. Okay, what is the name of the castle in the city where the performer of Never Too Loud was performed? Okay, that's our question. And then the first node, it came up with this initial plan. Okay, we need to identify the performer or the band associated with Never Too Loud to determine the city where they were first formed. Okay, then find out the name of any notable castle in that city. That's the plan, right? And initially it has selected, the agent has selected 2 nodes, right? Never Too Loud and then the album. So we have this initial notebook, which is simply a placeholder to collect the information as the agent travel through the graph. Okay, so initially it is empty. For these 2 nodes, now we collect the atomic facts. So here we are collecting the atomic facts. We update the notebook with those atomic facts, and then from the atomic facts we extract the chunks, and we'll check which of those chunks are relevant to answer the question. If they are not, as I mentioned in the graph here, the agent has the autonomicity to iteratively implement the steps defined at these 3 steps until it is satisfied that it has enough information to answer the user query. Okay, so the notebook is simply a placeholder to collect the relevant information as the agent travel through the graph. All right, so where are we? Yeah, atomic fact check. Yeah, here we are. All right, atomic fact check. Yeah, so the notebook, rational plan, yep, the previous actions and a notebook, right? Notebook and the current atomic facts and their corresponding chunk ID. So for each atomic fact we have so the 4 layers, those are connected to each other, right? So that we have the chunk ID. You have the following actions. Okay, first, for the given atomic fact, read the chunk using its chunk ID. Choose this action if you believe that the text chunk linked to the atomic fact, may hold the necessary information to answer the query. Okay, this will allow you to access more complete and detailed information. Okay, so we have the atomic fact, and from the atomic fact we are extracting the chunk, and we are determining if this has if the atomic fact itself has relevant information to answer the query. If it does, then we go ahead and extract 1 level above information, which is the chunk. Okay, if that's not the case, then we are saying stop and read neighbor. Okay, so for that nodes, we are asking the agent, okay, if you found out that this atomic fact is not useful, then search the neighborhood. Okay, all right. Okay, I will not go into details. These are intuitive. Please go through it, and if anything is not clear, please ask me in the comments. I will definitely answer. Okay, and as before, we have again some pydantic schema to enforce the output. We create the prompt, and then we create the chain. Okay, the Langchain chains. All right, and then since we are going to extract the information from the graph, we need to define those functions. Okay, which function to run, the agent will determine, but the function definitions we need to define. So these are like tools we are giving it to the agent. Okay. Now, if you look at get the atomic fact, so this one, it takes the key elements or the nodes as an input, right? So it takes these nodes, the green ones as an input to extract the atomic facts which are in yellow. So the way it does is it simply takes the key element and it is simply looking for this relationship has key element. Okay. The fact is the atomic fact, and the fact is connected to this chunk. So that way, since we know the graph different types of elements are connected to one another, we can extract such information. Now similarly, this is for extracting the neighborhood, and here we have atomic fact check. Okay. So again, we have the inputs, outputs, the response, so on and so forth. Now, what I want to show you one more thing is, so here we discussed, sorry. Yeah, here we discussed the agent has two options, right? Either to go for this or this. And similarly from here, the agent can go for this, or it can search more chunks. And from similarly here, from here also, it has two options to take. Okay, let's look at one of the examples. Okay, I'll show you the example. Yeah. Okay. So here for the action, for the next step action, here we are saying, is it? Yeah. So read the chunk or ignore the chunk and go ahead and explore further. Okay. So here we are saying choose this action if you believe that the text chunk linked to this atomic fact may hold necessary information to answer the question. This will allow you to access more complete and detailed information. Okay, so this is one action or one option. The second one is stop and read neighborhood. Choose this action if you ascertain that the text chunks lack valuable information. Okay, so as you can see from here, this is what we have done. So at the atomic fact, we have two paths. First path is go ahead and extract the chunk information if the atomic facts are relevant to the user query. If not, go ahead and search the neighborhood, okay, which is what one of the actions. We have similar actions for all three nodes, okay. Text chunk, now I will not go into the details, but this is exactly similar. So again, I stress, if you understand one of these nodes, understanding the remaining three nodes is straightforward in terms of syntax, how we define the node, the actions, everything is pretty much the same, okay. Text chunks and neighborhood. Yeah, and finally we have the response one, right? Here we have the final one where the agent synthesize the answer along with providing some rational explanation. Again, some background information. And here we are saying you have now explored multiple paths from various starting nodes in this graph, recorded key information for each path in a notebook. Okay, so the notebook contain all the relevant the context. Okay, now your task is to analyze these memories and reason to answer a question. Okay, again, some sort of instructions how it should do, so on and so forth, some examples, etc. And we create a prompt, and then again enforcing the output, and this is where the actual node definition is. Okay, the output must contain the answer, some explanation or the analysis, and all the previous steps which are taken starting from the rational plan. Okay, so all right. Okay, we have that, and these are those conditional edges. Okay, so since the agent choose a path in their node definitions, depending on the outcome, here we are directing to the next step. So as you can see, at this atomic fact, here we have two options. Either go ahead and extract the full chunk information if the atomic facts happen to be relevant to answering the question. Otherwise, search the neighborhood further. Okay, so if the chosen action is stop and read the neighborhood, we are selecting the neighborhood select, and otherwise the chunk check. Okay, those three conditions for the three nodes. All right, and finally, let's look at a couple of examples of invoking the agent, the LangGraph agent. All right, so here we asked a very simple question. Did Joan of Arc lose any battles? Okay, did Joan of Arc lose any battles? Okay, so it starts with this initial plan. Okay, it says to answer this question, we first need to identify specific battles Joan of Arc has participated. during her military career. Okay, so first we need to identify the battles, and then we need to determine the outcome of those battles to see which ones are lost by her forces. Okay, all right. So it has we are not printing everything, but then it went ahead to select the nodes, and these are the nodes. Okay, so Joan of Arc defeat, some siege of Orleans. These are the nodes. Okay, and then from these nodes we extract the atomic facts, and now we are checking based on the atomic facts if they are relevant to answer this question. If they are, then we go ahead and extract the full chunk. Otherwise, we search the neighborhood for further nodes. Okay, okay. The rational plan, the rational for next action after atomic check. Okay, because all these are relevant to answering this question. I mean, not just the nodes, but the atomic facts. Okay, the agent decided to extract the full chunk information. So it read the chunks. So each chunk has this chunk ID, which is what we have when we created the graph. And because it's a straightforward question, in just 2 steps, it extracted all the information needed. And then this is our final response, which contain the answer. Yes, the Joan of Arc did loot some battle, specifically these 2 battles. And then here is the analysis, which contain why it chose that or how it came up with this answer. And then if you look at this previous step, which is where we can see all the steps. So it starts with this rational plan, initial node selection, and then these are the nodes. For each of these nodes, it checked the atomic facts, and based on the outcome that these atomic facts are relevant to answering the question, it extracted this chunk. That's all we have in the notebook, and finally it went to the answering section. Okay, let's ask a question which is not actually relevant to this Joan of Arc. We are asking what is the weather in Spain. Okay, all right. So came up with a plan to answer this question. It need some reliable meteorological information, real-time weather, so on and so forth. Now it has extracted this node. It found out Spain is the relevant node, and now it is checking all the atomic facts relevant to the Spain node. For example, it's like this. Okay, let's say one of these nodes is Spain. Okay, so let's say this is the Spain. Now it has only this one atomic fact, so it is checking what that fact is. But since the Joan of Arc is not relevant to weather, it should find out that okay, this atomic fact is not relevant to the query, so I will not extract the chunk based on which this atomic fact is derived, which is exactly what we should be seeing here. Okay, since there are no atomic facts provided, we should move to another node that might contain the relevant information about the current weather in Spain. Okay, all right. It sets the neighborhood and it find out none of the nodes are relevant to this query, and so the possible candidates none. And finally, here is the answer. It said no, I could not give information about the weather in Spain because the notebook does not contain any relevant information. See, the notebook content indicates that there are no relevant atomic facts provided regarding the weather in Spain. And if you look at the plan, so the rational plan, initial node selection, it checked the atomic facts and it figured out that they are not relevant. So it has went to this neighborhood select. Whereas in the previous question, since the atomic facts are relevant, it went ahead to read the chunks. Whereas in this case, it searched the neighborhood further and figured out nothing is there, and finally gave the answer. Finally, here we have a more complicated question. Did Joan of Arc visit any cities in early life where she won battles later? Okay, so first we need to figure out all the cities Joan of Arc has visited in its early life, and then figure out which of those cities it has won the battles later. Okay, which is exactly the plan here. As you can see, here it has taken multiple steps. Okay, so as you can see from here, the previous steps, you see more steps, right? So we initially has the plan. Initially it has all the cities nodes and extracted the relevant information, and you can see in order to answer, it selected this neighborhood multiple times to extract more and more information. Yeah, so it had made multiple visits. It visited, traversed through the graph in a more complex manner in order to be able to answer this query. Okay. All right. To summarize, first we built the graph, this 4-layered graph. Okay, with hierarchical information, and then the high-level idea is given a user query, first the agent devise a plan, select a few nodes which are relevant to the query, and then from those nodes it extract the atomic facts and then check if these atomic facts are useful in answering the query. If they are, then it go ahead and extract the full chunks. Okay, otherwise it will explore the neighborhood. With these three nodes, the agent has the autonomic power to explore the graph in a more complex manner until it's satisfied that it can answer the question adequately using the information. So along the way, it collect all the information in the form of this placeholder called notebook. And the final step is same as in a traditional graph. All the context is provided to the LLM to answer the query. All right, as I said, it's a very long notebook, but the concept is very simple. If anything is not clear, do let me know in the comments and I will answer your queries. And if you find this video useful, please consider like, share and subscribe, and also share with anyone who might find it useful. Thank you very much.